Hello, and welcome to part 2 of adding and subtracting rational expressions. If you have not listened to part 1 yet, watch, listen, whatever, I encourage you to do so. It's in part 1 that we learn how to find the least common denominator and how to rewrite each fraction with the least common denominator. So the first 2 steps are in part 1 of the video. Now we're going to combine the numerators using the appropriate operations. All right, so once our denominators are the same, that same denominator carries through the whole operation. It's like having 2 pizzas, right? You order a large meat lovers and you order a medium supreme, and then you try to put them in the box at the end. You're not going to throw it in the medium box, right? Because you don't have the same pieces, the same parts. So you need to throw them in that large box. You need to throw them in a box where they have some commonality. And so our denominators are going to stay the same each time. That was a really bad example, but I'm going to stick with it. All right, here we go. Here we go. In order to add or subtract rational expressions, you must have a common denominator. It doesn't have to be the least. I'm just trying to make your problems easier later on. You must have a common denominator. Here we go. All right, so I look at 3a squared. And I look at 7a, and it looks like my least common denominator must have a 3, must have a 7, and it has to have a squared. So we're going to call that 21a squared. Fantastic. So take 8 over 3a squared, and I'm going to multiply it by something to get 21a squared. What is that? I'm going to multiply by 7. 7 times 8 is 56. 5, 6, 7, 8. So now I have 56 over 21a squared. Let's take a look at, we'll do it again. 2 over 7a. I need to multiply by something to get 21a squared. 7 gets multiplied by 3a. I need another one. So I multiply both numerator and denominator by 3a. That's 6a. All right. So find the LCD. Rewrite each fraction using the LCD. And now combine the numerators using addition, the appropriate operation. The denominator does not change when adding or subtracting fractions. So I'll have 56 plus 6a all over 21a squared. That's it, right? But since I can't add 56 and 6a, maybe I'll try to, do they both have a 3? They don't. They don't both have a 7. They do not both have a 3. They do not both have an a. I can't cancel these a's. If it's not in everything, I can't cancel it from anything. So I'll leave that one right there. All right, number 2. Number 2, it looks to me like my denominators are already the same. Anytime they are the same denominators, what we can do is simply combine the numerators. That'll be 2h plus 1 over an h plus 2. Keep in mind, those h's do not cancel, those 2's do not cancel. They have that plus sign, which really kind of messes them up. It encumbers them so they can't be canceled. I'm going to bring this one up a little bit. When you're dealing with common denominators, it's really nice to see everything as a fraction. So if you have to rewrite p, a variable, or even a number, 3, 7, 24, whatever, you have a denominator of 1. You always have a denominator of 1. So it looks like my least common denominator will be that p minus 5. So how can I rewrite p over 1 to have a denominator of p minus 5? Well, I need to multiply both numerator and denominator by p minus 5. That's p squared minus 5p. I know, super tempting. Don't cancel. We need to leave that denominator. And then once the denominators are the same, we combine. And then we try to factor if we can. Two things that multiply to be 3 and add to be 5. That's not going to cancel. The only thing I really care about is if there's a factor of my denominator in the numerator. If I'm not going to be able to cancel that denominator, I don't care if that numerator factors. I really don't care. For some of you, that means you have to completely factor. For others of you, maybe you could recognize that in the polynomial. It depends on how familiar you are with these polynomials. All right, it's lazy time. Problem number 4. H plus 14 over h plus 5 times h minus 4 plus h minus 6 over h minus 4. It looks to me like my least common denominator, which I always try to write down, will be h plus 5 times h minus 4, right? H minus 4 is in there. Both of these are in there. So instead of rewriting both of them, I only have to multiply this one. Now that's a little misleading because now we'll have h plus 14 over the least common denominator. And I'm going to multiply this one out. That's h squared plus 5h minus 6h minus 30 all over the LCD. Notice how I used LCD instead of rewriting the parentheses all the time? It's little areas like this that it's really easy to change your minus into a plus, change your plus into a minus, change just random weird things happen if you have to rewrite the same characters repeatedly. So I don't. I'm going to take h plus 14 and I'm going to add to that. I'm going to add these two together. I'm going to add to that h squared minus h minus 30 all over the LCD. That's h squared. My h's cancel. I have 14 and I have negative 30. That's minus 16 over. And now that all of that work is done, I'll go ahead and put my actual common denominator. So as I'm doing the work, I write LCD just to remind myself, hey, I have a denominator there. But really, I'm only doing the work on the numerator, right? I have my denominator set. I'm cool. I'm good to go. So I write LCD so that I can focus my attention on the numerator. But once that all comes back together, then I write them down because now I see a difference of squares. And that difference of squares is helpful because my h minus 4s will cancel. Now, if you do an awesome job of adding these together, but then you forget to factor and cancel and see if you could simplify it all, that's like giving me an answer of 14/21, right? Simplify your fractions, always. Simplify your rational expressions. Simplify your fractions of all types. All right, fantastic. My dogs are getting hungry. They're starting to be barky. One moment, please. I'm going to pause. And I'm back. It's almost like I never went anywhere at all, isn't it? That's because I didn't. I changed my mind. All right. A squared plus 5a minus 6 factors as a times a. Multiply to get negative 6. So one's positive, one's negative. Different by 5. So it's got to be 6 and 1. Because the 5 is positive, so is the 6. It's the bigger one. A squared plus 8a plus 12. To get a squared, we'll multiply a times a. To multiply to get positive 12, they'll both be positive. Multiply to be 12. Oh, they're both positive because the a is also positive. Sorry, same sign. This tells me they're both positive. Multiply to be 12, add to be 8. That's going to be 6 and 2. So it looks like our least common denominator has to have an a plus 6. They each have 1, so the least common denominator has 1. Has to have an a minus 1, has to have an a plus 2. So let's rewrite a plus 2 over a plus 6 times a minus 1. We'll multiply by, looks like we'll multiply by our a minus 2 here. Right, the only thing that's missing from the denominator. But I am not, oh yes I am. I'm going to multiply these. I forgot where we were going. I'm going to call this now the LCD. I'm going to call that a squared minus 4 over the LCD. The second one, a plus 3 all over a plus 6 times a plus 2. What is it missing from our common denominator? Are you serious? Do you see what I see? Do you see this mistake right here? I have an a plus 2. I multiplied by an a minus 2. A plus 2. None of that is correct. So instead of just crossing it out and making it look ugly, let's do it correctly. This will be a squared plus 4a plus 4. If you were screaming at me through the video, you're my kind of people. A plus 2, a plus 2. Make sure you multiply correctly, and that's why I try to write down all my steps, is because I make those steps on accident, because I'm human, as much as I hate to admit it. I don't have a problem admitting mistakes. I have a problem admitting humanity. Okay, when I multiply a plus 3 times an a minus 1 over the least common denominator, I will have a squared minus 1a plus 3a, so that's plus 2a minus 3 over the LCD. Okay, so we have everything over our LCD. That's fantastic. I have a squared plus 4a plus 4 plus a squared plus 2a minus 3. Our first step, that LCD stays the same. And now that I'm working with numerators, I'm only going to use that LCD so I don't think about the denominator at all. When I add these together, I'll have 2a squareds. 4a and 2a is 6a. 4 minus 3 is 1. And to rewrite my answer, I rewrite it with my denominator in place, a plus 6, a minus 1, and the a plus 2. Now, I happen to know that this numerator doesn't factor into anything meaningful. It really just isn't going to factor for us nicely. It involves radicals if you were to solve this quadratic numerator, set it equal to 0 and solve. But I only care if it cancels anything down here, and I know the 6 isn't going to work, the 2 isn't going to work, and I know that there's not going to be a minus 1 because this tells me that they're the same sign. This tells me they're both positive. So it doesn't cancel. I don't care. All right, that's adding. I know, it's a lot. Let's do some subtraction as well. We're only going to do these 3 problems, though, because subtraction is essentially the same. Essentially, what do I mean by essentially? That's the frightening part. It looks like the least common denominator is x plus 3 times x plus 4. That's fantastic. They're the same. So we can focus on just the numerator. Okay, so we're going to take x squared plus 5x and subtract all of 3x plus 8, keeping our denominator. This is an aside. So I'll have x squared plus 5x minus 3x minus 8 all over the LCD. Right? I want to write the LCD so I can focus on my numerator, make sure I take care of it appropriately. X squared plus 2x minus 8. Now that that's all combined together, I'll go back to the x plus 3 and the x plus 4. This is a fine answer, but I'm thinking possibly this numerator factors. And I think it possibly factors only because that x plus 4 sitting down here in the denominator is in the 8, possibly. To multiply to get x squared, we have x times x. To multiply to get a negative 8, one's positive, one's negative. Multiply to be 8 different by 2. I'm thinking 4 and 2. And the bigger one is positive, so that's an x plus 4 and x minus 2. Fantastic. I'm glad I went with my instinct and I factored. Had I not factored, I would have had an incomplete answer like 3/6. We all know that's the same as 1/2. And we have x minus 2 over x plus 3. All right. It looks like we need to factor our denominators completely. X squared minus 7x plus 12. I got to thinking about it. I think we're just going to go ahead and make a little bit of room here. X squared minus 7x plus 12. This will be x times x. Multiply to be a positive, so they're the same sign. The 7 being negative tells me they're both negative. Multiply to be 12, add to be 7, that's 4 and 3. X squared plus 4x minus 21. Multiply to get x squared, we'll have x and x. To multiply to get 21, we'll have a positive and a negative, negative 21, excuse me. Multiply to be 21, different by 4, so that's 7 and 3, and the bigger one is positive, so 7 and the 3. And we kind of had an idea that we're going to have an x minus 3, right? It's a 21. The minus had to go with the 3, so they have something in common. This is a textbook problem after all. X minus 4, x minus 3, x plus 7, x minus 4 happens once, x minus 3 happens once, x plus 7 happens once, x minus 3 happens once. The greatest number of times in any single denominator, they're all once. So let's rewrite our fractions. 5x plus 2 over, I had to get my cursor out of the way there. 5x plus 2 over x minus 4 times x minus 3. We want to multiply by that x plus 7. And so let's actually multiply that out. 5x squared plus 35x plus 5x plus 2. And I'm going to call that the LCD now. Scroll up a bit. Our second one is 2x minus 7 over x plus 7 times x minus 3. What do I multiply to get the LCD? Multiply by. Looks like I need the x minus 4. And we'll have 2x squared minus 8x minus 7x plus 28 all over the LCD. Now when I write these up here, I'm actually going to combine my x terms. So I will have 5x squared plus 40x plus 2 all over the LCD plus 2x squared minus 15x plus 28 all over the LCD. We put a little barrier here. That's my side work. That's my scratch work. That is, all right, so we're adding, we're not adding. This is subtraction. There's so many, each step, fairly straightforward. But there's a lot of steps that go into this. Okay, so I'm going to rewrite this because it's subtraction. I'm going to do this correctly. I just found a mistake. This 2 is not a 2. 2 times 7 14. If you were yelling at me, I'm sorry I didn't hear you. Oh, is this plus 14? Can't have that 4 hanging off. Minus 2x squared minus 15x plus 28 all over the LCD, which is 5x squared plus 40x plus 14 minus 2x squared plus 15x minus 28 all over the LCD, which is the longest problem ever. 5x squared minus 2x squared is 3x squared. 40x and 15x is 55x. And 14 minus 28 is minus 14. Now that I've completed the operation with the numerator, I'm putting back this denominator. It's multiplication, so the order doesn't matter. Let me see. I should put in everything correctly, though. These mistakes, they're super easy to make if you start getting in a hurry. Bad news. Now we really need to factor this. We need to factor this, and that hurts my heart and my head a little bit. Okay, so let's see what we can do over here. 3x squared plus 55x minus 14. If we were to multiply 3 times a negative 14, 30, that's a negative 42. We want to multiply to be a negative 42 and add to be 55. That's not going to happen. That's not going to happen because multiplying to be 42 with opposite signs, the best we could do is to get a positive 41. This will need the quadratic formula if we were to set it equal to 0 and solve. And for that reason, we can't factor it. All right, so we're good. Whew, I was afraid. All right, one more. This is what Bugs would call the coup de grace here. We got this. First step. Factor all denominators. X squared minus 4x minus 45 is x times x. Opposite signs. Multiply to be 45, different by 4. I'm thinking 9 and 5. And since the 4 is negative, the 9 is negative. Let's factor the second denominator. I see that 36 and I'm automatically thinking x minus 9. I haven't even analyzed anything yet, but as soon as I see 36, it has a factor of 9. If it would have been 35, I would have guessed my 5. This is totally guessing. To get x squared, x times x. To get negative 36, one's positive, one's negative. Multiply to be 36, different by 5. That's 9 and 4. Look at that. Step 2. Find the least common denominator. This will have an x plus 5, an x plus 4, and that x minus 9 they have in common. So we want to rewrite both fractions with the least common denominator. So we have 3x minus 7 over x plus 5 times x minus 9. What is this fraction missing? This fraction is missing the x plus 4. All right. And now we're going to multiply this. We have 3x squared. 3x times 4 is 12x. You know what? Why am I going to start shortcutting it now? Minus 7x minus 28 over the LCD, and I'm going to simplify that now. 3x squared, that's a 12x. Don't let me get away with that. Don't let me get away with sloppiness. You need to be able to read it, and I'm still trying. I'm trying. Here we go. Plus 12x minus 7x minus 28. So that's what? Plus 5x minus 28. My second one, 2x plus 3 over x plus 4 times x minus 9. Seems to be missing the x plus 5. So when we multiply that numerator, we end up with 2x squared plus 10x plus 3x plus 15 over that LCD. Now that we have the common denominator, we save it until the end. We don't really write it again. It gets confusing. 2x squared plus 13x plus 15 all over that least common denominator. Now, since they're both the least common, we have the least common denominator, we have them rewritten. As we go back up here, we'll write this as 3x squared plus 5x minus 28 minus 2x squared plus 13x plus 15, because they're both already over the LCD. All right. Let's not forget step 4. I'm going to throw that up here. So we're going to subtract our numerators. All right, so this is 3x squared plus 5x minus 28 minus 2x squared minus 13x minus 15. You'll notice that I actually took out that time to distribute that negative first. Now I'm going to combine. Why is that? It's so easy by the time you get to this 15 to forget that negative. So I like to actually write down this step so I don't forget, so I can pay attention just to the negative. Now I can pay attention to just combining. 3x squared minus 2x squared is x squared. 5x minus 13x is minus 8x. A negative 28 and a negative 15. That's going to be 2 less than 30, so this will be 2 less than 45. All over this least common denominator, which is x plus 5, x plus 4, and x minus 9. Now, this 43, can I factor this quadratic? Here's what I care about. This 43 at the end, right? That's not a multiple of 5. That's not a multiple of 4. That's not even a multiple of 9. So if it doesn't cancel any of these from the denominator, I do not care if it cancels or if it factors at all. I only want to factor it so that I can cancel it. And if I can't cancel anything, I'm finished. All right, you put a lot of work into this one. This video's kind of long, but I tried to give you enough examples that you can follow each step and do well. That's it. Thanks for listening to this long one. I'm going to go take a nap. You should too.